Okay, great. So, hi, doctor. This is the simulation for the 3D environment. However, for the 3D environment, when showing the map, there is two functions. There is one only that I publish the robot and the path, and the other one will publish the tree and then the robot and the path. Uh, when publishing the tree, the my computer is a little bit slow. So yeah. So if we want to change this, we can change it from here. Okay, so the publish tree function, it will publish the tree and the robot. However, the publish robot, it will only publish the robot. Great. Let's now run the bash file. This is RRT 3D. Okay. We don't want to forget to add the markers to see the simulation, and this is the simulation, and this is the number of iterations. Okay, 3000, and this is the tree that it will start to show off. So these are line lists, and I used line strips to show the path later when this is finished. Okay, during this time I'll go quickly through the code. So same as 2D, the RRT 3D is the main function, but for example here we have theta and psi, or let's say it's the pitch or the yaw and pitch angles. And in the visualization code, here I added this to transform from yaw, pitch and roll to qx, qy, qz and qw in order to publish the orientation for the arrow. Okay, and in the RRT function 3D here I did edit the check collision functions. For example, here the vertex list of the now cube is not a rectangle, so we have 8 points rather than just 4. And this is the implementation that is based on the implementation of the GitHub repository that I found, and I added another one that I'm using, where now we don't only use just 2 points. However, we use 3 points in the cube, which is because we assume that the robot will not jump. So I only checked for the planes that the robot may touch it. For example, this one, this plane, and sorry for this, yeah, and this plane and the other one. So not the above or the low one or the down one. Okay, and yeah, so ABC are for example are the 3 points of the cube, origin of the ray, direction of the ray, start and end node. And same for the intersect circle, which is here mainly it is for a sphere, but it did work because the robot cannot jump. And the Z range here, because the robot cannot jump, for example in the environment, the Z range is from 0 till 0.75, which is the highest, which is the height of the cubes, because the robot cannot jump over the cubes. Okay, and this is the simulation, which did not finish yet. Let's see it. Okay, I will pause a little bit. Okay, so welcome back. This is now the simulation, and this is the robot, which is an arrow, and the path in green. And yeah, and as we can see, it's going like the robot is is going with the path, and I mean the angles and about the orientation. And in blue, as we can see, the tree with all the visited nodes. Okay, and now the as we can see, it is the robot with the path in green. Okay. I'm sorry for the long time. The waiting time is absolutely not like this, but my computer is dying. Great. I will pause a little bit the recording, and then I will do another simulation just with the robot and path, because it's faster. Okay, so I will comment out this function, and I will only use this function, and then we go to the terminal and we run this bash file. Wait a little bit. We add the markers. And we can see the simulation here, and this is the number of iterations, and the path is found, and this is the robot with the path. As we can see, it doesn't jump above the obstacles, and we have no collision. Great. This is the simulation. Thank you, doctor.